In this video, I explain systematic random sampling with examples, detailed explanation, also discuss its advantages, disadvantages and fractional sampling. But if you are new on my channel Statisticians Club, please subscribe the channel. Introduction: Systematic random sample. A sample of size n is defined to be systematic random sample if it is obtained by choosing one unit at random from first k unit and thereafter selecting every kth unit after capital N units in the population have been serially numbered from 1 to n. Suppose we have a population of 100 units and k is the size of interval, and suppose we select interval size 10. So from first unit you select at random n unit, suppose that it is 5. After the selection of 5, we select each unit after interval 10, 5 plus 10, 15, and then 25, 35, 45, 55, so on 95. So these units are selected according to systematic random sampling. So I repeat, in systematic random sampling we select first unit at random and thereafter selecting all units with kth interval from 1 to capital N. Formula: the letter k is called sampling interval and stands some nearest integer. So its formula: capital N over small n, population size over sample size. Examples of systematic random sample: when number of units selected at random from first k unit, I1, 2, so on k, then systematic sample of size n will contain the units I plus k, I plus 2k, I plus n minus 1k. So if our I is 5, 5 plus k is 10, 5 plus 10, 15, 5 plus 20, 25, 5 plus 30, 35, so on. Here is the example. Suppose I is 7 and k is 20 and our sampling interval is 20, and our selection will be according to this 7, 27, 47, 67 and so on. What is fractional sampling interval? When sampling interval corresponds to some periodic or cyclic characteristics in the population, the systematic sampling will result in a non-representative sample. When sampling interval follows accidentally periodic or cyclic characteristics, so sample size will be non-representative, then such situation is called fractional sampling interval. Here we see its example. Suppose every 10th shop in a big market is a corner shop and sampling interval is 10. If random start coincides with the corner shop, so there will be the chances that sample will be highly non-representative and we select every corner shop. So this is the example of fractional sampling interval. When for avoiding this periodicity, example of fractional sampling interval, for avoiding this periodicity we use round off numbers selected. Suppose we select sampling interval 10.6 rather than 10. So after random start, suppose that first random is 6, it is 6 plus 16.6, 27.2, when adding 10.6 again 37.8, and after rounding 6, 17, because this is above the 0.5, So we consider it 17, 27, 38 and so on. According to this method, there will be the chance to select corner sharp as well as with other sharps. So it is so this sample is a complete sample because it can represent each type of shops, and there is greater chances to select each category of shops, not a corner shops. Resemblance between systematic sampling and stratified random sample. If population being divided into n strata and each consisting of k units, then systematic sample resembles with stratified random sample with 1 unit from each stratum. If our population divided into n strata, as you know, in stratified random sampling we divide population into homogeneous groups of strata, and from these strata we select k units. So we select units with k sampling interval and we select each one unit from each stratum. Then systematic sampling coincides with the stratified random sampling. If you want to see videos on stratified random sampling with detailed and allocation of sample size in stratified random sampling, then its link, you can find its link at the end of screen. Advantages of systematic random sampling: it saves much time and effort, it is economical. Systematic sampling has some advantages over simple random sampling. It is easier to draw because only one random number is required and then whole procedure continues. It distributed sample more easily over listed population. For this reason, systematic sampling often gives more accurate results than simple random sampling. And in routine sampling, systematic sampling has become a popular technique. Disadvantages: systematic sampling has the drawback of numbering or arranging the items in a large population. In systematic sampling, we assign numbers or arrange items of large population, and then we continue the procedure of systematic random sampling. This might be physically impossible if the population covers the entire country or a large geographical area. If our area consists of large geographical area or the population of entire country, so it is very difficult to utilize systematic random sampling because we assign numbers to whole population or geographical area. So this is very lengthy and tedious procedure. If you want to see videos on what is stratified random sampling, allocation of sample in stratified random sampling, objectives about sampling distribution, and video about simple random sampling, then click the link in front of your screen. Thanks for watching.